Hello, I'm Shahriar, a student of Tripoli at AIUB, and today I'll be demonstrating how to design a 5 GHz microstrip rectangular patch antenna using COMSOL. And those are the parameters I'll be using. And for the frequency sweep analysis, my F minimum frequency will be 4 GHz and maximum frequency will be 6 GHz. So let's get started. After opening the console, this window will pop up, and from here we'll click the model wizard and 3D space dimension, electromagnetic waves and frequency. We'll click add, then click starting. From here we'll click the frequency domain and click done. Now we'll go to the parameters one, and here we have to add the parameters for the simulation. I already have the parameters in a file, so I'll be using that. I have added all the parameters for the simulation. Now we'll go to the geometry, create a block, name it substrate, then its width will be A, depth will be B, height will be h plus hs, position will be center, and z-axis will be h plus hs divided by 2. Then under the layers, thickness will be ph. Now we'll create a work plane, and which z coordinate will be th plus hs. Then click build selected, and under the plane geometry, create a rectangle, name it patch. Its width will be r and height will be w. Position will be corner. XW coordinate will be minus a by 2 plus our left minus y0, and its YW coordinate will be minus b by 2 plus w by 2. Then build selected, and then we'll create a new rectangle. Its name will be matching, and its width will be y0 and y0. Height will be 2 into t1, and its width will be 2 into t1 plus w f, and its base will be common. XW coordinates will be minus a by 2 plus LF minus y0, and its YW coordinate will be minus q into t1 plus wf divided by 2. It's build selected. Now under the plane geometry, booleans and partitions, differences. Object to add will be holds patch and object to substrate will be matching. Then click build entering boundaries and click build selected. Now we will create a new rectangle. It will be feed line type solid. Weight will be LF and height will be WF. Position will be corner. XW coordinate will be minus A by 2 and YW coordinate will be minus WF by 2. Now click build selected. Again under the plane geometry, boolean and partition, we'll click union and this time we'll select the patch and the grid line and click build selected. Now we'll create an extrude. Its thickness will be TH and build selected. Now we'll create a new work plane and its plane position will be YZ minus A by 2. Look, build selected. The YZ plane. Now under this plane geometry, a rectangle into minus 4. Its weight will be WF and height will be HS plus 2 into P1 PH and its base position will be center. So common and click build selected. And the SW position will be minus WF by 2 and YW position will be 0 and will be build select. Then now we will create a sphere and its name will be far field. Its radius will be D plus 2M and under the layer its thickness will be Tm. Then click build selected. Now we will go to the definition. Click perfectly matched layer and we'll select all the part of the sphere. Next type will be spherical and now we'll have to add the materials. Add materials from library under the built-in will be air and copper. For air, it is already selected all the domains. For copper, because of the sphere, we cannot see the inside of the sphere, so we have to slice it. I'm using hide and click tool to remove the other part of the sphere, and it is not deleted, it just became invisible. Now we'll select copper. We will use the bottom and the top part of the patch. And then for the substrate, we will be creating a custom material. So for this, we will use blank material, and under the blank material, we will select the substrate, and in the rigid permeability, right into 1 minus 1i into 10d. For the rigid permeability, it will be 1 and conductivity will be 0. Now we have assigned the materials to the respective domain, and under the electromagnetic waves and frequency domain, we will create a far field domain, and it is automatically selected. And then again we will take the lamp port, and for the lamp port it is crucial. So we will zoom in and select the part. I have selected the lamp port, and now for the mesh sequence type change to physics control mesh to user control mesh, and from here predefine to creating codes to define all of the codes, and click build mesh. Now the software is measuring all the parameters. If we zoom in, we can see the mesh part. Now we will go to the study. Under the study frequency domain, we create range. Now for the start, we will F minimum, step will be 0.2, and stop will be maximum. And click replace. Then we'll click the compute. It will start to computation. If I zoom in the progress bar, the computation has started. It has completed 4% computation. Now click compute to start the computation, and the computation started. Due to the low configuration of this laptop, it will take several hours. So I'll be stopping here. I have already taken the data, so I'll be opening that. And if we go to the result section, the S parameter is this, and the age radiation pattern is like this, and this is for the 5 gigahertz resonance frequency. For the E, we use this, and this is the electric field non radiation. So this is the data. Thank you.